Hello, I'm gonna show you how to do problem number 3. Number 8 tells us to determine the change in the range of a projectile. We have this formula that we know that we use for change, and the formula that they're giving us for that projectile is r equals b squared over 32 sine 2 of delta. So what we're going to do is plug in all of our values from this equation into this one. We're gonna substitute delta r equals, we know the function for this one this function needs to be plugged in here. So v squared, we know our initial velocity is b, and 2,500 is our initial velocity. So we're gonna plug in 2,500 squared over 32, and we're gonna multiply everything by sine 2 over delta. Which one? The second one, because the formula tells us that we always need to start with the second one. So we multiply by 11 pi over 180. And we do the same thing. This is one part, and we're going to do the same thing minus, because we have these, we're going to do the same thing for the other one. So we know our initial velocity is 1,500 squared over 32 sine multiplied by sine 2 over 10 pi over 180. And when we plug this in the calculator, we get 195.312.5. These numbers for this one multiplied by this, what gives us this in the calculator is times 0.37460. This is one part, and then minus the same 195.312.5 times the answer of this, which would be 0.3420. We multiply these two numbers for each, and we get a total of 73165.35. This will be plugged in the calculator, and we will get this number, minus we plug in this in the calculator and we get 66,800.80. Then we subtract these two numbers to get our final answer, which will be 6,364.55. This as a change in rate allows us to use differentials to approximate rating change. We have this formula, and what we need to do is first to differentiate the one they gave us here in the top. So we know that dr equals y prime, it will be our formula differentiated, which would be b squared over 32, and when we differentiate sine of 2 the angle, we get 2 cos of 2 and the angle. All of these, we're going to multiply it times the d of the delta, which is here. We know that if we subtract this minus this, we're going to get our d. This equals 2 minus. So our answer here will be 1 pi over 180. Once we have this done, we can start multiplying everything in the calculator or plugging in values. We're gonna plug in values first. On the b, we substitute that 2,500 feet squared over 32, because this one is our initial velocity. We're gonna multiply everything times 2 cosine of 2, in which the angle that we're gonna be using here will be the one that we got first, our initial one. So times 10 pi over 180. And we multiply all of this equation, as the formula says, by our delta that we got here in the top. That would be 1 pi over 180. Once we plug in everything in the calculator, this gives us 195.312, 312.5 times 1.8793 times our 1 pi over 180, and the final answer will be 6,406.24. This is our change when we approximate using differentials.
So for the problem 3, part C and D, I'm going to help you solve it. In part C, they're asking you to interpret the results within the context of the situation. In my opinion, I think it's really clear to see that if you change the degree to another number, for example, in this problem, that 1 degree, the practical result will be really different since it will go more far. The next part is to respond to a very good question, that is, under which circumstances is it better to calculate the actual change and when the approximate change? Well, in my opinion, it's better to calculate the actual change when you want a 100 accurate solution, since this information comes from the actual situation, f of x, and it will be really helpful for you to be exact. For example, while measuring a fence for your house or any situation that required any detailed number. In the other hand, the approximate change is the estimate of the real change among two values. This information comes from the tangent line, so use differentiations to approximate the change when you don't have any rush or you don't have any calculator.
Okay, so this is problem 13. And we need to integrate the problem. We have the u to the n type. So this is your u. First, you need to write your u, which is 2x minus x to the third. Then you need to derivate this, which will be 2 minus 3 to the x squared. After this, we need to find what we want. The leftover is 18x to the square minus 12 dx over. We will cancel this over this, which will be 18x squared 12 over 30. We need to get the common factor so we can cancel this out. In this case, it will be 6, so 3x squared minus 2. This and this cancel out, and you have a negative 6 du. After this, so this is our leftover that was replacing this and this. Now you need to rewrite this. That will be, we need to always include this of the antiderivative. We first put the 6, negative 6, the u, with the number we have, 7 du. We always add 1 to the exponent, to the n. So we will have negative 6 u to the 8 plus c. Then we over 8, because when we apply this rule that you add 1, you need to divide by the number you have in the exponent. In this case, 8. This will be negative 3 over 4 u to the 8 plus c, leaving it as the u to x minus x to the third 8 plus c. And this is your final